Welcome back after lunch. I hope you all had a very big carb load and you managed to stay awake during this exciting talk by Olaf Hartong. He's going to talk to us about MDE, under the hood. Take it away.
Thanks, Ben. Ooh, that's loud. All right. Hey, everybody. Thanks for being here. I hope indeed you will stay awake because it's after lunch, which was great. So just briefly, I'll introduce myself. I'm Olaf Hartong. I'm a Dutch guy from Falcon Force, which I'm one of the founders of. I'm a Microsoft MVP. For the people that don't know it, I can say a lot of shit about Microsoft and not get offended. No, but jokes aside, right? I can be critical, and I should be. Apart from that, I am a security researcher. I do a lot of threat detections. I build a lot of detections. That's one of the things that we do. I used to be a documentary photographer. I have two boys who I really adore and who miss me very much. And apart from that, I like warm hugs, of course. So just moving on. So what can you expect to be here, right? So I don't want to bore you too much. I want to talk a little bit about Defender for Endpoint, what it can do, what the capabilities are, and it's a short talk. It's only 5 minutes, so I can't talk about everything. What kind of telemetry can you expect to gain from it as a defender? But also, where does it actually get its information? Because it's nice that you get it into a portal, but where does it come from? Because this is where attackers can actually start fiddling with it. Or you might have some blind spots which you need to augment. So, of course, every tool has a configuration. So we figured out a way to read it. So I'll talk a little bit about it. And I'll compare it to Sysmon, which is probably known to most people. I won't introduce it, but it's an awesome tool that's freely available as well, where you can maybe augment what you're missing. So first of all, a little bit of a capability outline. I tried to stay in the theme, so all the pictures that you might see are actually pictures that I created myself on a Navy ship in the Netherlands. Not very interesting, but just a byline. So technically, Defender for Endpoint is a huge tool, right? It's a commercial product from Microsoft. It's basically the pro version of Defender, just the Windows Defender AV engine, which is still part of it. But it also contains attack surface reduction, which is a configurable tool. It has exploit guard, there's exploit application control, which is a sort of application whitelisting service. And then, of course, there's the EDR telemetry, which probably will take most of the talk. There's some incident response capabilities where you can stop processes, isolate machines, these kind of things, what you would expect from an EDR. On top of that, they have some vulnerability management capabilities, so they can scan like a, vulnerability management tool, but slightly less mature maybe. There's a network sensor, so it actually looks around the network as well, sees if it finds weird hosts that it doesn't recognize. And there's some DLP capabilities. And not everything on this list is actually something you pay for, right? Of course, the AV is just on your Windows box when you install it. And even ASR and application control are just there. So first of all, AV, everybody has it or uses it up to a certain point. It's easily bypassed, of course. It's just signature based. So, but still, yeah, why not use it? There's some great research on the signature database by Camille Mogi. Sorry if I mispronounced that. It's a French researcher, really, really interesting stuff. So he decompiled the whole database. Basically, you can figure out what it's triggering on. You can configure a bit of it. So you can tell it, hey, I don't want to see certain events, or I trust this directory. And there's a couple of things which you need to be aware of, because attackers will probably, if they land on a box, try to exclude their own binary first and foremost. And the weird thing is, so there's a couple of things to keep in mind. So if you exclude a process, which a lot of attackers actually, if I look at my sandbox telemetry, fail at, they try to whitelist their own binary, but the only thing that it does is basically whitelist the stuff that it spawns. So it still gets detected. But and the other thing is to keep in mind, so if you apply an exclusion to the Defender AV agent, still all of the other capabilities are working. So EDR telemetry is still being generated for it, which is nice. And also ASR, which I'll get to in a second, will still be active. So still, there are a lot of protections in place. So if you want to actually use it for a legitimate binary in your organization, you have to have multiple exclusions. Because it's a sort of amalgamation of all kinds of tools. So the AV is a different team, then ASR is a different team. And they They work for the same company, but they don't always work together, not as effectively. And there might be some benefits as well in having these kind of things. So if you want to learn a little bit more about the AV engine, there's a couple of great tools. One of which is Defender Check, which actually also gets flagged as a malicious tool. So I checked Defender Check with Defender Check against Defender. And you basically can see what the cool thing about the tool is that there is also a Python version built by somebody else. But basically what you can see is what it would trigger on. So this is great if you're more of a malware developer, because then you can see, hey, why is it triggering? What should I change? Usually it's just a string in the code, like this one. It's just a standard out string. If you remove that, it will actually work again. But that's AV, right? Everybody knows that. So slightly more interesting is the attack surface reduction rule. So this is a component that's also available on every Windows box. And there are 16 rules that you can configure basically through a registry key or group policy, which allow you or allows the engine to block certain activity. For instance, an Office process starting PowerShell or command.exe, something like that. Definitely useful. You can, by default, it's off, so nothing happens. But you can configure it to be blocking stuff or even only auditing it. So you can just see what it would do. And that by itself is super valuable already. And then all the telemetry, if you have the Defender for Endpoint component, will get logged to the central storage, so you can actually see what happened on those boxes, what it would have done. So yeah, one of the things to reiterate, if you run this, if you run Windows boxes and you have this running, definitely enable it. Even in audit mode, it's super valuable. You can at least see what would have happened, right? So it's a good indicator that somebody's fiddling with it, or Teams is just being annoying. But there's a lot of things going on your Windows box that might hit it as well. So back to that previous slide, just to explain the graph that I didn't do. This is research done by Palantir, who's done a lot of great work together with Matt Graeber on attack surface reduction and some of the other Defender components. And basically they made a graph of what should be safe, what might need some additional reviewing, and what is very problematic in most organizations to enable. So not everything can work. So definitely do audit mode on the right side of the graph. On the left, you should be mostly fine, depending on your organization. I've seen weird stuff in some companies as well that broke everything. So these rules are, again, rules. And they're written in Lua. The same Camille reversed those as well. He decompiled them. And basically looking at them, it's again, a sort of signature-like, I hope you can read this actually, but it's a snippet of it. So the rules are basically regexes that look for paths or files or command lines. So basic stuff. Still, as I mentioned, it's super annoying for an attacker if he gets blocked with the initial execution, sorry. So still valuable to use. And on top of that, you can build your own custom detection rules to see what was actually going on if it would bypass it. Because you can still detect that. It's recorded, right? Because it's a process that is started. Another component, which I won't get into that much, is Exploit Guard. That used to be EMAT for the people that are as old as I am. It's a nice feature as well, where you can block some weird arbitrary code, some process injection things, and some weird child process creation events. It's relatively limited. It can block some known CVEs, these kind. But probably if you want to go deeper, you want to enable the Defender for the application control, which is really nice. It's really powerful. It's also very complicated. They created some nice wizards now to generate some of the ruling, which will help you quite a lot. But this is a very delicate process. You want to test and reevaluate quite constantly. Because you can break boxes or have people in your company prohibited from working. But you can do some fun stuff with it, though. You can use it very maliciously, which I won't go into now. I found some weird stuff that you can do, which basically disables any kind of blue team help. So that matters. So you can kill EDRs and these kind of things. But again, yeah, I'm on the defensive side, so I don't say how. Figure it out yourself. But basically, you can use this for good, right? You can block all kinds of malicious known drivers. You can do it on signature-based. You can do it on process chains. It's very powerful. Again, Matt Graeber did amazing research on it. He has a whole series on YouTube that you should follow if you're into that. But let's move a little bit more towards the EDR component, because this is where it gets useful. Even though it is an EDR, right? That's never a single source solution. So it's nice. It's pretty good. I think it's one of the better ones, actually, to be honest. I played with a lot of them. And one of the nice bits is it has quite a rich set of telemetry. So even though it doesn't alert on a lot, like all of them do, because there's a billion ways to execute an attack, you at least get the telemetry to build your own detections for this. And this is where it starts to get nice, but also I start to get curious, because where does it get it? What do I get? And how good is that telemetry? Especially because it's a sort of single source solution. You pay X amount of money per endpoint and you get unlimited storage or not. So you don't really know. But yeah, it's quite broad. So it can, the only thing that you have to keep in mind, like it's a solution that you pay for, so they control everything. They basically determine what type of events you will get. So there's no configurability in terms of how noisy you want it or these kind of things. For the alert side, maybe, right? You can threshold some stuff, but telemetry-wise, it's just whatever Microsoft deems fit for you is what you get. And we'll get into that a little bit more. So some of the events also, therefore, are supremely or heavily sampled. Because, you pay $5 a month, which is not that much at scale. And if they have to store all of your network connections, for instance, that's going to cost them a lot of money. Impact performance will be slow. Everybody's complaining. So nobody's happy there. So these are heavily sampled. And some of the other ones are even worse. And they try to tap into a lot of data sources just to have a sort of full picture on your machine. So the event tracing for Windows is supremely used. It's very heavily used. There's 65 different providers that it's querying or getting data from. And this includes all kinds of private ones that they instantiate when you install it as well. And one of the ones is now in Windows 10, that's called the Threat Intelligence provider, which I'll show you a little bit more about in a second. And these can only be accessed through Microsoft's allowed, I think, AV vendor. So it's you can still access it, and I'll show you that as well. But it's a little bit more work. So as I mentioned, everything goes into the cloud. You get all kinds of nice visualizations and tools around it. The detailed information, like the full telemetry, is only stored there for 30 days. You can't extend that. Then you need to export it, which is relatively easy. They make it accessible to you. But this is what you get within the price that you get. And there's a sort of timeline overview, which is a condensed data set, which isn't really nice to go through, but it's a sort of better visualization if you want to go quick and dirty. But if you want to go further, then probably get it into Sentinel, Splunk, whatever you're using. On average, I think what we've seen so far for most of our clients is like 20 megabytes per endpoint per day. So it's not a lot of data, still very valuable. So what can you expect? So if you just open up the portal, there you get a nice overview of all the tables. So it's a sort of, it's a table structure. And within the tables, there's all kinds of fields that you can query. And there's all kinds of ways to basically see what you can do. You can just visually click through it. You can also request it through the query language, just to show me the schema, and then you get all the fields that you can expect. And if you want to go a little bit deeper, then within some of those fields are actually subfields. So it's very confusing. And especially on the device events, there is a table called action type. And then if you look into the action type, there are actually 180 plus different actions that it logs. So one of which is the ASR events, but there's all kinds of other things like named pipes and USB connections and everything that you would want. Basically, it's super rich. They actually have good documentation within the tool on it, not on the website, weirdly enough. And the only thing that is sort of annoying, they are so agile in their development that they release the documentation often before the actual implementation is there, which is kind of nice. Usually for everyone, it's an afterthought, right? Nobody likes to document, but at least somebody at Microsoft does. So thanks for that. But they also don't do real change logs. So how do you know if there's a new feature? There might be new telemetry that you can actually start utilizing. But maybe you have to scroll through it every day. So what we started fiddling with is, of course, if you go open the hacker view of your browser and you get nice JSON output, And you can actually start utilizing this. So you can, with the Azure command line tool, you can basically generate a barrier token and talk to this API, which isn't documented. It's basically part of the portal, and then you can just extract all of that information. And maybe if you want to go really anal like we do, is we build a pipeline around it, and we do a diff every 4 hours and see if there's new functionality coming out. So that might help you, right? It's a bit over engineering, and I would love Microsoft to just have a sort of release log where they just expose what they have. But this is what it is. So, yeah, do you need custom detection? So maybe some people saw Adam's talk this morning, where he was talking about coverage and breadth according to the Atomic Red team. So what I did is I basically ran most of the Windows scripts, which is about 600 maybe. And some of which failed because it wasn't domain control, it wasn't domain joint and everything like it. But I only got 177 alerts, which isn't very scientific, I know. It's just spraying a lot of shit at it, and maybe it fired. But, I mean, there is something to deduce, right? Even if only half of those scripts were successful, which there were more, but then there's only 177 detections, out of which 10 less were mapped to MITRE ATT&CK. So there's some stuff that we probably need to do ourselves if we find it interesting to detect that. This slide is old, deliberately again, because I don't want to help all the adversaries here. But basically what we did is we looked at all of our clients, what type of detections are actually triggering an action environment, plus we hammered it with all kinds of badness that we did ourselves. And basically we got a sort of overview. The darker the color in this image is basically a diversity of attack scenarios that were detected. So there's still some gaps, and that's fine. It's an endpoint tool. It's one tool. You can't cover everything. But there's also some room for improvement if you want to start building your own detections on top of this. Next, what I wanted to look at is basically how, so what kind of telemetry can I expect? And this is the theoretical bit. So basically what we did, I worked together with the Rodriguez brothers. They have the OSAM project, which maps all of the coverage and then connects it back to MITRE ATT&CK. And the cool thing that we can do then is basically we have all kinds of actor groups who do tactics, they execute techniques, and there's data components, and there's data sources and data components in MITRE ATT&CK. But what we can do then is basically map it to events, what type of data is it, and even to the provider. And what you can then do basically is start generating these kind of fancy heat maps where you can show what kind of data can I expect from it. And this is theoretical, right? So it's not necessarily said that everything that is now colored will be generated, because there's filters and sampling, as I mentioned. But basically, you can already see if I want to cover this technique with a custom detection, where should I start looking, which is kind of helpful. And of course, I like the Bloodhound tool, so I also started graphing it. Not necessarily very legible yet, but there's a lot of data potential here, right? And if you start zooming in a little bit more, hopefully it's legible again. So if I only want to see what kind of registry-based detections can I potentially build, this is already slightly more useful. Which fields do I need to look at, and these kind of things. So then we're at the point, so we have a lot of data, but where does it come from? And this is, as I mentioned in the beginning, it's important to understand basically how your tool works if you want to be able to rely on it and maybe supply some additional telemetry next to it. So there's a couple of things that it does. So Defender for Endpoint, or that uses, one of the things that they do is they use a device driver, which sets a bunch of kernel callbacks. And basically what they are is they tell the kernel, hey, if a new process is being created, tell me. And then you get the full details. The same goes for registry keys, for image loads or driver loads, as you will, name pipes, and a bunch of other ones. So one of the interesting things here is that it only, basically what you're looking at is Mimikatz, because it was easy to. And you can query all these kernel callbacks that are registered. This was the easiest way for me to visualize it. And basically what you see is that there's a pre-operation and a post-operation. And the difference is, as you might expect for a process, so the pre-operation is when the process is started, and the post-operation is when it's terminated. And you see that there's only a callback for Defender and for the EDR component. So these have different drivers, and not for the process termination. So this is already something that you could have also learned from your telemetry, but now you at least know that it actually doesn't even look at it. Not even underwater, because there is a difference between what you see in the portal in terms of telemetry and what they actually record. That's way more. And if you look a little bit below, for the people that know of Sysmon, that actually does both. That's the only distinction on kernel callbacks that I could find between the two. And then again, I figured, hey, let's visualize this because it might be useful later. And basically, I mapped all the kernel callbacks that you could set to the data components in MITRE. And then I could also map it back to which fields can I expect the data to be in Defender for Endpoint. Again, a lot of eye candy, but can be useful in some ways because then you can also start querying detections and then or techniques and see what you can actually start querying. It's a quicker way that I like to use a lot. As I mentioned before, it also heavily relies on event tracing for Windows, which is sort of built into the kernel. It's the underlying messaging structure for all telemetry, basically, or most telemetry. And there's some interesting things. So that basically is set up in 3 layers. You have providers, you have consumers, which kind of makes sense, right? They're friends. You show something, somebody else takes it. And then there's tracing sessions, which is a sort of a consumer-like object, but it works in a slightly different way. It's a different way of hooking to that data. Again, Matt Graeber did a shit ton of great research on this. So if you want to learn more, definitely read these 2 blogs, because I don't have the time to explain everything now. So the weird thing is that Defender for Endpoint uses some of their own proprietary ETW providers, which basically uses sort of aggregation point. So they stand up their own infrastructure, so to say, where they use a lot of their own messaging providers that they hook to and then ship it off, which was already kind of interesting, at least. And Matt Graeber built a tool, Matt Graeber again, I love the guy, to basically see which of the ones are actually built into the code. So you can relatively rely on the truth of that. And then what I started doing is basically looking, okay, where does that data go? Because usually you don't get live stream data from Defender into the portal. So it's stored first locally, and then at a certain point, either time or volume, it gets shipped off. And then the database locally is flushed and it starts really buffering up again. So this is it's kind of interesting. I started fiddling with it a little bit. You can't access it directly, so you need to be a system at least to copy the data. And then, yeah, it's locked, so you can't really tamper with it that well. It's probably possible, but yeah, it's quite a lot of work, and there's easier ways to nuke it. So I don't see any attack potential there. And the fun thing is, if I look in that database, it's called Asimov events. And Asimov is a sort of Halo reference that from 2014. It's very old. And that used to be the unified telemetry client, which is now Diactrack agent. And why is that significant? Well, we'll see in a bit, but it's kind of interesting that they have a sort of very old reference in there, even though the product doesn't exist for that long. So I started playing with CLider, which is an open source tool available on GitHub, which is very useful to basically subscribe to all these ETW events to see what's being logged. And it's highly configurable. You can tell it what you want. I used a very basic approach, so just mentioned the ETW GUIDs that I needed and started ingesting that a little bit. So some of those providers are actually protected. So you need to have a protected process flagged to your tracing process. Otherwise, you can't access that telemetry. But that's kind of nice because that at least protects also a little bit from tampering or listening in. And there's some proprietary information in there that you might not want to expose to your competitors, even though it's super simple to get into. So there's a couple of tools that you can use. PPL Runner is a really nice one where you can elevate your own process with a vulnerable driver and basically get still access to that same telemetry. It's also funny that while playing around with these protected processes, you can also attach a debugger with some magic that my colleague Gijs found. And you can basically start live debugging the Defender engine. And he found a vulnerability where you could spoof all the telemetry to the Microsoft portal, which was just accepted. So you could generate fake alerts, you could generate fake telemetry, and have all kinds of fun as an attacker. Fortunately, that's patched, and it's gone now. Almost not possible anymore to spoof it. And now it's at the scale that it doesn't really impact any agent. So back to those traces. So if you start tracing it, you get all kinds of fancy JSON objects. And within those JSON objects, there were these fields that looked a little bit like base64. So I just copied one and decoded it. And then I saw, indeed, hey, there's some plain text in there. And this, for the people that work with Windows, this looks like an event ID to me. Like this is simple PowerShell event log, but it's even the same ugly structure. So that was kind of interesting. And then there was all kinds of gibberish around it, which turns out to be serialized data. So Microsoft uses Bond, which is a product that they built. It's an open source tool that can, based on a certain schema, serialize it. And then it's just more efficient for them to transport it and parse it later. I tried finding the schemas in the code, but yeah, I'm a horrible debugger. And even worse at reverse engineering, so I haven't found those yet, but they're probably in there because it needs to know how to serialize it. So that might be a nice exercise for somebody else to do. And then the other thing that was interesting is I saw that PowerShell data, but I don't see, if I look at which subscriptions are there, I couldn't see it. So that sort of piqued my interest a little bit. And also, it was an event log. So apparently, MDE makes use of event logs. So I started looking a little bit more. And I remember, so I saw that Diatrack thing as well. So I started looking into that, which is an old service that does all kinds of telemetry recording, but somehow they're tied to Defender. And they actually had the subscriptions to all those event IDs that I was looking at before. So also the PowerShell one, the Diatrack service logs those. And interestingly, you can also just disable that service and then everything is gone. So it's kind of weird that they rely on a standard Windows component for such important information, and it's unprotected. So I started looking at the protections as a local admin. I can just stop the service and there's no telemetry anymore. Interestingly, later I learned that in 2017 there was also a talk around the early stages of this tool. And back then, the researchers found that also that service wasn't protected. They talked to Microsoft, one patch level later, it was fixed. Yet on a new Windows box, it's not. So somebody forgot a regression check or something like it, and nobody sees it, right? Because it's, most of the time it's not that important. But for an EDR, you kind of want to have a reliable way of delivering some stuff. So this is one of the few things as an attacker you might want to actually utilize. And the rest is up to you to find out. Especially this one. So the configuration, every product needs to be configured because otherwise it doesn't know what to do. As I mentioned, Microsoft maintains this, so they make sure that you get registry keys, these kind of things. So there's all kinds of things, and it's downloaded every couple of hours or every time they make a change, which is quite a lot actually. Sunday is their fun day. They do a lot of releases then because most of the team is based in Israel. That's a Monday for them. So there's a lot of new stuff every week, basically, that gets added, tweaked, all kinds of updates. And basically, it's quite a large config. It's stored locally in the box. Again, I won't tell you how, because there's also a lot of people watching on the stream that might have different kinds of interest than the people that want to defend the company. So go nuts, have fun. It's not the easiest one to find, but yeah, basically. What does it have? So what's in there? So all kinds of telemetry sources, so the kernel objects, but also the ETW providers, registry keys, file paths, where it might look for file creation events. So a lot of interesting stuff to know as a defender, but also as an attacker, because then you know where you can have your bypasses. Because all kinds of stuff is excluded as well, because of noise or trust or all kinds of things. So very interesting. And another is where we already noticed that there was sampling and capping involved. That's also configured. So some of the ones you can just see, okay, why do I only see one DLL load for this process? So it's actually because there is a limit to it. Otherwise you get flooded. And there's also all kinds of dynamic data collection. So they run a lot of signed PowerShell scripts, which they mostly exclude in that config to be visible in your telemetry because they're quite noisy and ugly. But they gather all kinds of local information from a box that they can't gather from the logs, which you do want to know in some cases. And also the agent configuration. So how long should it retain its data, what is the buffer size, all kinds of just normal stuff. So it's quite a lot. So it's like 70,000 lines of JSON code, or code, but text. And there's those 65 ETW providers. There's about 500 registry paths that are being monitored, and about 60 of those commands that are being executed frequently, and all kinds of settings for even if they detect that you're in a high latency environment, then it starts changing the caps and some of the other things, so that there's just limited amount of, but more important information going out. And then all kinds of, child processes that are trusted from certain parties or not. So PowerShell, for instance, of course, has a lot of child processes. So there's a local limit that is changed for that one, for instance. So all kinds of things like that. And then there's that list of ETW providers. So this is a very small snippet of it. This is a very interesting one, which is only available for EDRs and AVs. That's the one we just looked at. So from a sample, so that was interesting. But I also saw that one, the security ETW, which sounds already interesting, of course, because we're looking at a security product. But first, that threat intelligence one, I'm good on time. It's basically a baked-in Windows 1. And if you're a validated AV, you can access it. And there's all kinds of API calls that it logs. So process suspension, process injection, all kinds of APIs that are heavily used by attackers. And also some of the native Windows tools. But you'll at least get that telemetry there. So it can basically subscribe to it, log it, and these kind of things. It's quite fun. And if you use ETW Explorer from Pavel, you can basically just go through to the manifest. And you can see what kind of data you can expect. You can also start listening to it, but you need to have an elevated process, as I mentioned before. So back to that security ETW, I was very interested in that one. So I basically started looking at the GUID to see what it's actually doing, or what does it say. And then I quickly learned it's just the security auditing tool. So apparently it actually uses it, right? So I started digging through the config, and then you can basically see every event type that it looks at. So this is a simple one where it just looks on, I think this is a log on events, right? Yeah, so it's a 4624, which for most people that ever worked in a SOC is quite familiar. It's just device log on events. So somebody logs on a box on Windows, this is generated. And then you can even see, like on top, there's a global cap, I think. Yeah, so there's 1,000 per 24 hours of log on events that are logged, which is on most machines, especially endpoints, is quite fine. And then you can also see for which fields that holds. So that it's a subset of fields. In this case, it's the target username, and then the logon type, the IP address. So it's already restricted. So if you have 1,000 logon events from that specific set of fields, the 1,001 doesn't get recorded. But if it comes from a different IP, for instance, you'll get it again. So again, they try to rate limit it a little bit. So as you do. And then you can see basically configuration for all the fields and everything and how it's being filtered. It's quite useful. I started looking at, okay, if it uses the security events, which event IDs does it actually look for? So this is that list. Not very lengthy. But then I was interested in, hey, what kind of audit categories are tied to those? Because not everything is logged by default on Windows. And basically there's 4 settings that you can do. So you can set no auditing, that's basically not a setting, but then it's a 0. And if you only want to log the successes, you get a 1, and so forth. So then I started looking, okay, what settings do I need to have on my box to get those events generated? So I started configuring, or I started doing nothing actually. I just installed a new Windows box and looked at what's there by default. And what do I need, basically? And then all the ones you still can read are the ones that are not set properly by default on a default out-of-the-box Windows installation. And there's all kinds of reasons, because some of them are hyper noisy, especially like the firewall stuff gives you a lot of logs. So the vendor, so we have some blind spots there, right? So and then the Defender team already tries to help you a little bit, because they also recognize that problem, and they enable some of those audit settings to at least give you some more visibility, but they still keep quite a bunch off because of volumetric and these kind of things reasons. because it also runs on a server. Generally, most people ingest all the logs from a server, and then it might triple or quadruple just because they installed Defender, and nobody likes having that. So they want to give you that same option. The only sad part is that they didn't document this part. So I'm probably not the first to find it, but at least now you can benefit from it as well. So yeah, there's some things that you need to do. Make sure to check your GPOs, because even though Microsoft in their wisdom changes it locally, you might have a group policy that overrides it and then it's still gone. But also you want to make sure that you actually look at that list and see, hey, there's a couple that I actually am interested in, because you're losing EDR features. If you don't ingest the boxes alerts or the logs from those boxes directly, then there's no harm in enabling those. So basically you should go through that, because otherwise you miss valuable detections. So basically what I did is I created the ugly PowerShell script that goes through all of your group policies and checks whether the settings are actually there or not. Code is horrible because I'm not a programmer, but it works. So that's good enough for me. You can find it over there. You do need to have the RSAT tools installed, so preferably on an admin box. I promise you, there's no beacons in there, but really, yeah. So there's some gaps. So you can hopefully fill a bit with enabling the audit settings, but you could also augment it if you're a capable team which is sizable. Then you can start looking at maybe another tool to enrich the data. I'd still recommend most people to first look at all the capabilities of your first tool before you install a second one, unless you have a very immediate use case for it. But basically, I compared it to Sysmon because I did a lot of research in the past on that and still use it actively. So there's a couple of benefits and a couple of less good things, or differences at least. So Sysmon, first of all, is very simple, and you have to configure it. So that enables you to have full control over it. Downside is, of course, you have to maintain it, so it's up to you. But again, that's if you have the team and the space and the time for it, definitely go for that. One of the other downsides is it only logs, right? So it will tell you something happened. It won't do anything about it. You need to build that yourself as well. And then, as I mentioned, it's best applied probably to augment Defender, or maybe have a full parallel setup, which is even more work to maintain. So again, you need to take care of that. And then on the flip side, MDE is fully maintained, which has also the downside that you can't influence it really. You can ask Microsoft to add it, and if they agree, they might do it, or sometimes probably will do it, depending on how useful it is. The telemetry set is actually a lot richer, and it has a response capability. So you can also tell it to kill something, or at least isolate a box. Downside, probably the biggest one for me, is that the telemetry is sampled. So a lot of it you can't do. You can't do beaconing detection, for instance, if you would want to do it on your endpoints. For now, they're working on something else, but for now it's not there. And basically what I did is I also put them head to head. So most of the telemetry is the same. As you already saw, they both do the kernel callbacks, and some of it is different because they do heavy sampling or capping. The only one that's super annoying is the image loads or the driver loads, because that's sort of YOLO. There's no real explanation, also not in the configuration, how it logs. So you can have 10 the same boxes. They will have a different image load telemetry. That's the only one that really stood out to me. I can't explain. And then Sysmon has some unique features, like the clipboard contents that you might be able to use during an incident response engagement. And it can retain deleted files, which is pretty useful, again, if you know that your box is compromised. It can also flood your box, so be careful with it, because disk space is still something that can run out. And then on the Defender side, there's some additional logs. There's the rest of the slide, basically. So there's a lot of different telemetry there as well. And basically, if you start mapping the visual again, then there is some overlap. There is some differences. So there are some gaps to be filled on both ends, depending on which one you rely. So, I'm actually good on time. So basically, as a sort of wrap up or a conclusion, is try to figure out what your tool is actually doing, how reliable is it, and how complete is it? Because those gaps are usually the ones that hurt you in the end if you don't know about them. If you know about them, you can even, maybe, or you accept it or you do something else with it. And also try to understand how they are actually detecting stuff. So it's like we saw in the ASR rules examples, sometimes it's very stupid. It's not bad that it's stupid, but maybe you need to do something on top of it or next to it, something like it. But as long as you know what is actually going on, that will help you already, because then you can take alternate measures. And one of the things that we try to do is continuously reassess this, because they make a lot of changes, and usually there are improvements. So knowing that there's new capabilities, knowing that there's new visual stuff or new logs, new fields in logs is actually very nice, because then you can improve your detections and maybe cover stuff that you didn't do before. And definitely go to Henry's talk in track 2 at 3, because he's basically showing you the red team perspective from this side. So that will be fun. And basically, that was it. I'm out of time. So if there's questions, I'm happy to help you. If not, thank you for attending.
Thanks, Olaf. We do have time for questions. Any in the room that you haven't already asked?
Well, both. But no, I'll stick still with Defender, because it's very easy to deploy. Sure, you have to pay for it, but it's so rich, and you have that blocking capability that you don't have on a Sysmon tool, for instance, which is a lot more work. You have to set up ingestion of the logs for every endpoint. There's a cost to it as well, so it's way more complicated, and you have to build all of your detection rules instead of where you get quite some good stuff out of the box. We actually have a service, without being very commercial, but we sell detection content. Basically, that's part of our research work. And we still have hundreds of detections that you can use on top of it, but it depends a little bit on the maturity of the company, right? We even had a question from a client that is like, hey, this is a great detection, but what do I tell my SOC to do with it? Because sometimes it's very edge casey to investigate. So this is also why all those EDRs are always butchered by red teamers, that it's easy to bypass or it's shit or whatever. Definitely some are, but it's also they have to cater to a very big audience. So there's always people picky enough that you need to augment it, which is fine, right? That keeps our job fun. So yeah, for people on the stream, I'll try to recap it quickly. But the question was, if you enable the firewall events locally, does it collect it for all 3 settings? So that's public, domain, and the other one. And if you do that, doesn't it flood the logs quickly? So the event log system itself has a rotating feature, so that if it's set up normally, then it won't fill up, because it's just rotating and it's recycling. And the Defender component looks at all 3. It just looks at what's coming into the event log, and it will, again, sample the shit out of it. So you will get the important stuff. If it's new, you'll see it. If it's repetitively doing it, it will ignore it after a certain threshold. So it won't fill up. You will have the visibility. But then in Defender, that's sort of taken care of by the agent. If you do it with your own agent next to it, Splunk, whatever you have, then you have a problem. So that's why it's not enabled by default, because then it might give you terabytes of data extra every day that you also need to do something with. So the question is, can you enrich or make it more verbose, and can you customize the logging that MDE shows you? Answer is sadly no. I've had several talks with Microsoft about this. They might consider doing it in very minute changes. But the problem for them is that they need to stay in control of the flow of data coming to them. Because if you make an error, which could happen, you might flood. It is a shared service, right? So you have your own bucket of data, but there's a search head cluster or search cluster that is basically shared resource. So if you overfeed it, then other people get impacted by it. Plus, Microsoft has to pay your storage bill, which is nice, but they don't want to do that. So I don't think that will change on the large scale. There are vendors. So as I mentioned, they do ingest more data than they expose to you. And this is something that I've been talking to them as well, which is, I'm probably not the common user, right? I acknowledge that. That's fine. But who cares? If the common user doesn't even look at the telemetry in the first place, then they can just show me everything that they have, right? So that's something that they might change in the future. I do know that there are some MDR vendors have a direct feed, and they sometimes get a little bit more. So if you also have, if you're a demanding client, you might be able to coerce Microsoft in being a little bit more verbose as well. They do it, but it's super rare. And mind you, this is a huge service, right? So they have billions of endpoints going with their telemetry to it. So it's at scale, it's still performant, which is impressive to me. Yeah, so the question is if you want to use Sysmon next to it, should I use the log analytics agent? If you want to use Sentinel, yeah, you need to, because you need to ingest the telemetry somehow. Log analytics agent would be nice. Another method might be Windows event collectors. The only downside of that is that you also might need a VPN or whatever if your people aren't on site. So probably, yeah, an additional agent is something you would need, yeah, regardless of. Yeah, but that's a config on the Sysmon side. So if you want to fill in the gaps, then you first need to understand the gaps, and then you can augment them with your Sysmon config and tell it to only log certain stuff that you're actually caring about, and ship that off to that gets shipped to the event log, and then you need to ingest that somehow. Yeah, and Microsoft now has a new agent for the Azure Monitor agents. You can even do XPath filters. So you could still have a full Sysmon configuration, use the Monitor agent to only look at the stuff that you want to get that to the cloud, and have the full Sysmon telemetry local for IR or... Exactly, yeah. Ideally, you don't want to do that because that's just costing you additional money where you won't be building detection rules on top of in the first place. Yeah. Cool.
We got a question from
Awesome.
the...
Oh, is it one more?
Yeah,
One more? Oh, you got a
yeah, there's the question from Discord is from Dre. Question in Discord from Dre, who is obviously the intern Dre, and it's not Dr. Dre.
Well, you know now. Right?
So he's wondering how Olaf would detect Screen Connect, Altera Agent, Zoho Remote Access, Splashtop, AnyDesk, those kinds of things.
If that's being logged, is that the question?
How you would detect it.
Oh, how you would detect it? Well, yeah, that's difficult because inbound connections are sampled, so you won't always see it. You do see when the process is being created. So if you see AnyDesk and you don't use it in your organization, that's not sampled. So process creation logs are there. So that's probably your first indicator. That's
so process creation, but not the actual once it's created.
Yeah. So if it's running and it receives a connection, that might get logged because that's sampled. So you don't know for sure that it happened. Not always. So if you have that, yeah, then you need to augment that probably with your proxy log or something like that. And Henry wants to say something about it as well.
For those on the stream inside the room, there's a suggestion that all of those use the screenshot API. So, some of them do. Sorry. So you could look at the screenshot API activity. Right? Did I say that right? Okay. Thank you. Thanks for the question, Dre. Good for the interns.
Yeah. All right.
So thank you all for
Thanks,
coming.
guys.
If there are no questions, you will want to be back here for Tony Sager, who's the next speaker. I mean, you wanted to be here for all of this one too. So thank you,
you.
our speaker.